Welcome back. So this video is going to function as a sort of crash course in how the internet works for someone who wants to be a developer. So it's meant to take you from avid internet user like me, who maybe doesn't understand a lot about how the internet works because you don't have to someone who still uses the internet all the time but understands a little bit about how it works at a high level. It might be surprising, but developers really don't need to know the very low-level nitty-gritty about different data protocols and how they work and this TCP/IP stack and things that you may hear that are very intimidating. That's an entire discipline. There's entire college majors and courses devoted towards how the internet works at a low level. As a developer, things are abstracted away so that we only need to understand the very basics more than your typical user of the internet. But we don't have to be experts on all this very intimidating nitty-gritty stuff. So a few things we want to do here. We want to understand at a high level how the internet works. Things like HTTP, IP, domain names, URLs, what are all those? How do they work together? We want to understand the difference between front-end and back-end development. Also full stack, where does that fit in? And then we also want to be able to view the HTML on any website. So the first thing that I want to do here is actually watch a video. So the link is in the slides. It's also in the description of this video. I'm going to go ahead and open it up. Feel free to watch this on your own. I'm going to watch it in this video and just pause at a few moments, highlight a few important pieces.
Have you ever wondered what happens when someone in England visits the World Science Festival's webpage? First, their computer needs to ask the World Science Festival server for a copy of that webpage. The computer sticks this request into a virtual envelope called a packet, wrapped with specific information about that request, including the World Science Festival's IP address. The computer sends this packet out of the house and below the street via large underground copper wires. It passes through small regional networks before ending up here at Telehouse North in London. Telehouse North is England's main internet hub. The IP address on this packet tells the hub that the World Science Festival server is actually in Los Angeles.
The first thing I want to just highlight there, the user in this case went to a website, World Science Festival website, or typed that in and then hit enter. And all of this is happening before the user sees anything. The idea is that a user is asking for a website or requesting it, and that's what it's called. It's an HTTP request. So when I opened up this video, youtube.com/this URL, when I hit enter, I'm asking for the contents of this page. And that has to go all the way to YouTube somewhere, and they have to send it all the way back to me. So far, we're still just getting the request to the right place.
So Telehouse North sends the packet out as light across the Atlantic, over fiber optic cables buried deep beneath the ocean. The packet ends up here, 60 Hudson Street, New York City, the largest internet hub on the East Coast. This hub sends the packet through a series of regional networks connecting New York to Los Angeles, where the World Science Festival server resides. The server reads the request and gets ready to send the web page to England. But web pages made up of images and text are too large to send as a single packet of data. So how do we get it back to England?
So at this point, the request has made it all the way to the correct server, and it's told it, I'm looking for this page. And so now everything is on the return journey, going from the server all the way back to the computer that asked for this specific page.
Group of 5,000 tourists visiting New York City in a single gigantic tour bus. They are way up in Harlem, but they want to visit the Statue of Liberty before it closes. But it's rush hour on a Friday. There's no way that giant bus is going to fit through those crazy congested streets. So they decide to get off the bus and spread out. Some take the subway, some take cabs, a few rent bikes, and some even take kayaks down the Hudson River. How they get there doesn't matter, as long as they get there on time. Likewise, for the internet to work efficiently, this web page is pulverized into thousands of tiny packets of data, each one wrapped with all of the information it needs to rebuild itself in England. The packets are sent to LA's One Wilshire hub, which checks the traffic report before sending them off. Through miles and miles of land they travel, checking in through different hubs. Like our New York City tourists, those packets don't care how they get there, as long as they get there as fast as possible. Most of them will go through 60 Hudson in New York, where they are redirected back to England as light, riding a fiber of glass as thick as a silver dollar. Then back on copper wire through regional British networks until all the packets reach their destination and this epic journey, it all happens in about a second, along with trillions upon trillions of similar journeys that happen each and every day on this remarkable, easy to take for granted network of networks we call the Internet.
So hopefully you found that video fascinating. It certainly blows my mind, even, to someone who does this a lot and who uses the internet a lot, makes websites, makes applications. It's still so amazing, the process that happens behind the scenes, just for every single page that loads. Just to reiterate, let's take this example of when I go to this URL, udemy.com/courses, and I hit enter. Remember, I'm asking for something and I'm getting something back. I'm requesting something and the server is responding. And there's a lot of stuff that happens in between, but that's the core concept. So the very first step that happens, and actually before I start there, I want to let you know, this is not something you need to memorize. This is purely conceptual stuff that is nice to know, but you can always come back, you can look this up, you can rewatch this video. The one thing I really want you to memorize and to be confident in is this idea of requests and responses, asking for data and a server giving you that data, and then your browser displaying it. So this step here, when I go to a URL, I hit enter. The first thing that happens is my computer needs to know the exact address to send a request to, which is just like when you send a letter, you need to have a unique address. No home has the same address as another home. They might look the same, but they're in a different city or a different zip code or a different country. They are unique. So we need that address so that our request goes to the right place. So this thing called a DNS, it takes that domain name, udemy.com, and it translates it into this IP address, which is a string of numbers and dots. This is a unique identifier. Once we have that, then we actually send the letter. It's when we actually make the request. So in this case, when I hit enter, I am figuring out, or my computer's figuring out, what is www.udemy.com's IP address. Okay, we have the IP address. Now let's send a request asking for the courses page. So we make a request with an HTTP request. We'll talk a lot more about what that is and what they look like. And remember, it's not just one way direct shot there. Basically, the request bounces around from server to server until we get to the server we're looking for. So when we get to the server, the first part is that the server is going to figure out, what am I asking for? Am I asking for the home page? I'm asking for /courses page. Am I asking for the sign up page? The become an instructor page? There's all sorts of different pieces here that I could be asking for, and they're all different. So the server's job is to figure out what to send back. When we do backend development, that will be your job, figuring out what content to send back. So then the server often interacts with the database, it pulls out information, and it makes a combination of HTML, JavaScript, and CSS. So then our server responds back. It sends us this combination of HTML, CSS, and JavaScript. It's a bunch of code. It's not very readable for humans. And our browser steps in and it turns it into this. It's the whole job of our browser. It takes that information and it makes it easy to understand for humans. So this process happens on every single page you visit, and you can actually see the underlying HTML and CSS on any page, and JavaScript. So there's a few ways of doing it. In Chrome, and this is why we're all using Chrome, you can let's go to this page here. I can right click and click View Page Source, and it opens up a new window that actually contains all of the HTML, CSS, and JavaScript that is the underlying source for this page. Same thing on YouTube, right click, View Page Source, and so this is on every single site. So there's no way to hide this. The whole job of the browser takes this and it turns it into this. So browsers are definitely complicated things. The good thing is you don't have to know how that works. The browser, that's the whole job of a browser. It takes that code and it turns it into this. So another way you can do it, there's a shortcut in Chrome. You can do Command Option U. On a PC, I believe it's Control Option U. If not, you can just right click in Chrome and view it as well.